Good evening to everyone who are joining in this live interaction session. I'm Indu, and you must have listened to a lot of my lectures in the recorded mode. So this is one chance where you get to speak with me directly. So if you have any queries regarding the topic or subjects as such, feel free to type the questions in the chat box, which will be monitored here, and then this is one chance where you get to ask your queries live. Okay, so before I start, what I'll do is I'll take the liberty to introduce two of my excellent students who have been helping me assisting this whole course. So we have Vinayak here. So you want to say quick hi?
Hi.
Okay, and we have Manu.
Hi.
Okay, perfect. Yes. What we'll do is I'll take the liberty to start the questions that have been posed through the questionnaire, and in between, if you feel any questions that is bothering you, feel free to type in the chat, and then I'll read it out loud, and then we can start discussing. Okay. So now I'm trying to open the questionnaire that was shared, and let me read out the first question which was posed. So it says, finer resolution of DEM for flood hazard mapping presents better and more precise picture of vulnerability assessment of an interest area. But DEM from SRTM is of course a resolution, and hence using LiDAR UAV technology is also not very common in developing countries due to various policy and security issues. So the question is, what can be done so that minimal compromise with data can be done? Is it DEM from SAR interferometry can be a solution, but it again also uses reference DEM, or can there be another option? So this is the question, first question which I got through the response. So as I understand, the learner wants to know whether fine resolution of DEM can help in flood hazard mapping. So let me start by mentioning that whenever we say flood modeling or flood hazard mapping, we use say a hydrodynamic model, and there are many inputs that go into the model, both which are static as well as which are dynamic. And the uncertainty of flood hazard maps, or for that matter the uncertainty of outputs that come from a model, depends upon the uncertainty in the input that goes into the model. Of course, DEM is one such input that goes into the model. There are many more. There can be rainfall, there can be land use, land cover maps, and so on. And another source of uncertainty is the inherent model structural uncertainty. That is, what kind of model are we using? Okay, and of course, use of DEM is important. It does play a prominent role when it comes to generating flood hazard maps, but then it is not the only source of uncertainty. There can also be the uncertainty from inputs, model structure, and the inherent structure of the model that also gives uncertainty. So I would say that when we are talking about DEM, of course you can go with an open source SRTM DEM, or if you have access to LiDAR DEMs, you can also use it, but that alone may not how should I put it, may not influence. That alone is not the sole parameter that influences the output of a flood hazard map. There are many more, depending upon, of course, the type of floods and type of models that you use. So this is in fact a very interesting area of research in which many of the students here are also working, trying to understand the parameter uncertainty that gets manifested into the simulations when you're trying to use a hydrologic model or hydrodynamic model for that matter. Okay, so to answer your question specifically, compromise or assumption is always there when we use modeling. Okay, to minimize it, we try to use the best available data products. Okay, I won't worry much about them, whether it is from SRTM or Aster, but then of course if you have access to high quality DEM, you can always use it. Okay, that is the answer that I have. Do we have anything in the chat? No. So what I'll do is I will take the second question. Okay, so let me read it out loud. When we do snafu unwrapping, which method is most effective in the sense of accuracy, snafu plugin, Sigwin, or external snafu using command prompt? Okay, so I think this question is referring to the tutorial that we had on radar interferometry. So see, the latest version of Snap, it has a direct plugin. Okay, it has a direct plugin for Snafu, and older versions did not have that, which is why we were using Sigwin on Windows or direct Linux. But then if you have a direct plugin, you can use it, and that will make your life easier in terms of the objective that you're trying to accomplish. But to answer your question, see, the Snafu code as such, it's written in C and it is compatible with any operating system. And so accuracy may not be an issue whether you are using it through Sigwin or through a direct plugin, because underlying algorithm, as long as it is same, accuracy does not matter much. And there won't be any change in accuracy. That is the direct answer to your question. But then as the version of Snap also has a plugin, you feel free to use it. And when we were conceptualizing and creating the material, this was not available. That is why we have used the installation through Sigwin and so on. Okay, I hope that answers your question. In case something is not clear, feel free to chat in the chat box, which is also being monitored. Okay. Now, what was the next question? Okay, so here I'm explicitly not reading out the names, okay, because I want to focus more on the questions which can cater to a wider audience. So the next question is, when I now also research aspirant MA Geography from JNU decided to proceed further in urbanized coastal environmental risk with alarming climate change scenario. Okay, my basics to these remote sensing technique is weak, but after completing this course, I'm having confidence to deal basics and answer related to microwave radar remote sensing utilization in my research methodology, which is good, thank you. However, much detail of PS INSAR, D INSAR, and most recent SBAS D INSAR is not the part of this module, but I request you to please mention SBAS D INSAR and how it is superior over other two types in live interaction session. Okay, so firstly, thank you for this very interesting question. So when we started devising or deciding on how many modules should be a part of a course like this, microwave remote sensing in hydrology, we wanted to make it simple in the sense that we wanted to represent all the sophisticated terminologies used in radar remote sensing in the most simple terminology as possible, which is why I did not explicitly include anything much about INSAR, because when I start talking about PS INSAR or for that matter SBAS D INSAR, it automatically becomes equivalent to a master's or PhD thesis. That is the level of research that goes into each of these topics, which is why I have not explicitly included it. But just to answer your question, we know that by now all of us know that phase differences, they are used for ground deformations and for monitoring landslides, earthquakes, and so on. And we do have several techniques for measuring this. Now, in PS method, just to answer your question, I will give you a superficial answer because I don't want to go deep, as it is part of a much, I would say, advanced stage of this course. So to superficially answer your question, when we say P INSAR, it uses only coherent pixels, okay, coherent pixels for generating interferogram. And when we say SBAS, it uses pixels that are interpolated over a larger area using methods like Delaunay triangulation. So, it results, SBAS INSAR, D INSAR results in a better accuracy than PS INSAR. So because the noise is less, and the kind of methodology that goes into it is a bit superior when we compare it with PS DIMSAR. So that is the basic level of answer that I'm going to provide right now. But if you are more interested, feel free to drop message in the chat window or drop me an email, and I can direct you to those research papers which have done extensive study in these methods for measuring land deformation. Okay. All right. Now, do we have anything in the window? No. Okay. Now, let me take up the next question. So, firstly, let me read out the question loud. It says, I'm working on my mangrove biomass calculation using Sentinel-1A and LOS-2. I want to calculate using band math option. Is there any other option? That is the first question. And next, I want to know the process of quantifying biomass in the mangrove forest. I got some empirical formulas through some literature. I know this is a very interesting question. In fact, it is a question that is, something that I wanted to work on as well. Because, mangroves, they are both unique as well as complex. Okay. Because they are inundated during high tide and they remain muddy during low tide. And when it comes to radar remote sensing, we use long wavelength microwaves in the P band and L band to study about mangroves biomass estimation. And to specifically answer to your question, rather than worrying about band math options or tools, I would refer literature for more fundamental relations on how to estimate biomass using P band or L band. Okay, I can even refer to a paper, Villard et al. 2016. He has published a very good paper on how to use radar remote sensing for biomass estimation, and there are many more. Of course, studies are, I think, less compared to other topics, which is why this area as such is more interesting. Okay, so the upcoming missions which have P band can be used for biomass estimation, and the present missions which have L band, they can also be used for biomass estimation. But then please don't rely on band math, because then it's just plus minus of a few bands and you may not understand what goes behind. Okay, so please refer the literature on how they are trying to physically understand the LOS data or the Sentinel data, C band data, P band, L band data, and then try to use it for biomass estimation. So that would be my answer to your question. And again, if you are not able to find the relevant literature, drop me an email, and then I can lead you to a couple of literatures, a few over India as well, which have used L band for biomass estimation. Okay. Yes, good evening. So what we are doing is we are trying to answer the questions one by one, what were mentioned in the response sheet which was shared. Do we have any other questions? No? Okay. So if you have any specific question, please feel free to type in the chat window so that I can read it out aloud and then we can discuss. Yes, I see Irfan. Good evening. So how many participants do we have for this session? Okay, so thank you so much. I see your message, Jai Krishna. So yes, that was the whole purpose. That is to simplify this course. Thank you. Glad that you liked it. So what I'm doing is whatever is being posted in the chat window, I'm able to read it, and then um, yes. So yes, Irfan. So I request you to please share the recommended book. I'm unable to access these. Okay. So there is a very good book on microwave remote sensing by Dr. Ian. Okay. Which you may find in the bookstore. I'm not sure if they are available in the online, like stores like Kindle, Uh, so that one book I will definitely recommend because it tries to explain the concepts in a very simplistic manner. Okay, so it is Introduction to Microwave Remote Sensing, yes, by Dr. Ian, actually Professor Ian Woodhouse. So maybe if you can, yes, paste link. Do you have that option to paste? Yeah. Of course, there are many more, but then I would prefer this if you are a beginner. But if you want a little more sophisticated, discussions, then there are many other books. Okay, so there we are trying to post a link for your benefit. Feel free to type in the chat window so that I can read them loud. Yes, please discuss on Saral mission. So just a query, now, Saurabh, have you worked on the Saral mission data products anytime? Or, can you give me a background on what do you find it interesting in the Saral mission? What application are you trying to address? Okay, so while we wait for your response, I can mention that you can find more details of the Saralautica in the ISRO website because it is an Indo-French mission which helps us to estimate water levels using radar altimetry. Okay. So if we can paste the link of Saral, maybe it will be helpful. Yes. Yes. So we are trying to share the link which will help you understand from ISRO website which has more details about Saral mission. I can't leak out the questions. Yes, yes, Irfan. Yes, Ulabi, and yes, this book is also there, which is interesting. But when you go through the preface, you will understand which book you find more inclined to read further. Yeah. In fact, whenever you pick up a textbook on microwave remote sensing, there is always some blend of electronics or electrical coming in when the discussion is on antennas, and yeah, that is unavoidable. But then, this book that you have listed is a very good book as well. Okay. So I am trying to read Saurav's question. In ISRO Bhuvan website, can I get data from Saral? So you can directly access data from Saral, but I have not accessed it from the Bhuvan website. Maybe you can paste the link of where you can access it from. We'll paste it shortly. Is it the Mostat? Yes. Yes. Feel free to type your queries, and in the meantime we'll try to paste the website which gives access to the data from Saral, as Saurav has asked. If you remember, in one of the tutorials or lectures, I was showing you how to access data from MOSDAC, isn't it? You have to create a login ID, password, and then how to browse through the folders which has the data products, especially on the tutorial which was on Doppler weather radars. And if you remember, I had showed you how to click on the radar data from TERLs. Okay. So did we have? Yes. I think this link has details. Can you post this link, please? Yes. Yes. So please feel free to browse the link for Saral dataset. We are just posting a link now. Yes, this is for the MOSDAC site. You will get more information on how to access. Okay, now let me go to the, yes. Thank you so much, Sohaib. Study material. So we were just discussing that, whatever was posted earlier, we can use that, as well as there is a book known as Introduction to Microwave Remote Sensing by Professor Ian. We can use that. So, okay, thank you. Thank you. And yes, we have another question on impact of incidence angle. How do we know? And one more question, I will read that as well because it is related. What are factors to consider to select incidence angle range of data? So I'm assuming that when you say impact of incidence angle, you are referring to the satellite borne sensors. Okay, how does, say for example, the microwave brightness temperature depend on different incidence angles? So let me give you the example of complex terrain. Say the Himalayas. Say satellite with a certain instrument is trying to scan the Himalayas in different incidence angles. Hypothetically you can assume 10 degree, 30, 40, and so on. So what happens is complex terrains as such, it is impacted by several sources of error when we try to scan it, and incidence angle adds more to it because some amount of energy gets scattered out from the field of view of the sensor, and because of complex terrain and because of incidence angle as well, some amount may only reach back to the satellite, and much will move in all different directions. So there are research based studies which try to understand what are the, say for example, by brightness temperature values or backscatter values for that matter. How does it vary with respect to incidence angles for different land use land cover types? Say for agriculture, how does it vary? For complex terrain, how does it vary? So a wide range of research is being done to answer this question. So I may not have a single answer because it depends upon the angle, the sensor, the product that you are trying to use, and the application, and the land cover type, whether it is sea, it is different, agricultural area, it's different, complex terrain is different, and so on. Okay. Now I'm scrolling down the chat window. Thank you. Okay. So feel free to type in the chat window so that I can read it out loud as well as I can try answering them. So I hope that the tutorial sessions were helpful for you as well, because we had intentionally made it hands-on, as they say, until you do and work actually on the problems you don't understand. If you just listen to me speaking, you may learn less, but if you also try to work out on hands-on exercises, you try to learn more, much more. Okay. Yes. So I'll go to the first question. Any reference? I would urge you to send me an email mentioning the specific application you're looking for and whether you are trying to access a radar data incidence angle combination or a radiometer incidence angle combination and the application. Then I will be able to suggest literature, papers which have worked on similar areas. Okay. Yes, only module 1 is uploaded. Yes, we can get PDF of other modules from 2 to 6. Yes, we can do that. Okay. So again, feel free to type whatever comes to your mind with respect to this course. Anything else? Yes. Another question we discussed up to interferogram. How do we generate DEM from INSAR or DINSAR data? So again, I am not able to see your name, but I'll call SK. So SK, just drop me an email and I will share the specific links of master's thesis as well as papers who have worked on this particular area. Okay. Now let me read out the next question. Deepak is asking, is there any method to estimate soil moisture for crop root zone? That is a very good question. And by now, through this course, you may be aware that the penetration depth increases for different, penetration depth is different for different bands in microwaves. And root zone soil moisture estimation is a very, very important area of research. There are studies which try to use P-band microwave to study root zone soil moisture. We can have field-based studies wherein you keep a sensor and you see the vertical profile of soil moisture. That can be done. And there can be other methods wherein you use satellite-based data to estimate soil moisture. But then when you talk about root zone, you need wavelengths like the P-band, which can help you learn more about the root zone soil moisture. Or another way is you can try to use modeling. For example, you try to work on a hydrologic modeling or hydrodynamic modeling, wherein you want to simulate soil moisture at different depths. Okay, that is another possibility. But again, that is an indirect way of estimating soil moisture, which of course depends on the assumptions used by the model. So as well as the inputs that go into the model. So yes. Oh, okay. Sampath Kumar. Yes, yes, Sampath. Now I remember. I did receive a few emails from you. So nice to meet you. Then, okay, I'm reading out the next question aloud. What is the best satellite data for hydrology purpose exploration? So let me try to rephrase your question. Is the question what is the best satellite data for hydrological applications? So okay, so if it is, then it depends upon which variable you want to study about. Okay, so if you want to study about precipitation, I would go with a TRIM satellite or GPM satellite. If you want to study about the groundwater, I would go with GRACE satellite. If you want to study about soil moisture, I would suggest a SMOS mission or a SMAP mission. And if you want to study about water levels, I would suggest Saraloltica or JSON or Sentinel or SWOT. So it's application oriented. When you say hydrology, it covers a broad hydrological variables and broad, the area as such is very broad, isn't it? So you pick a variable, what exactly you want to study in hydrology, and then look out for which satellites are more suitable to understand that particular variable. Okay, but then the plus point is nowadays we have a lot of data products which are being stored in repositories that is free for public to access. So which means we can work with big data much more efficiently than say 2 decades before or so. That is the plus point. Okay, now whether the effect of foreshortening increases with increasing incidence angles. The foreshortening as a topic, it was covered in one of the lectures, isn't it? So you should tell me whether the effect of foreshortening increases with incidence angles or not. Okay. Now I'm reading out the question from Shakti. Which band is especially used to calculate the water quality or sediment deposition of reservoir? Very good question again. You know, um, Whenever we are able to see turbidity um, through optical remote sensing, when we try to say look at Landsat images, we try to look at the coastal areas or areas after a flood, wherever there is more sediments deposited, there is a change in the spectral signature, when we can see the difference in the image spectrally. Whatever is visually visible, we use optical remote sensing classification to understand about that. But then we are not going to the field, taking a sample of water and trying to measure the BOD or COD values. Okay, so we are not directly trying to understand about water quality parameters. Whenever we talk about optical remote sensing, what we do is we try to spectrally understand the difference and then try to attribute it to several sources. The same applies when we are trying to use microwave remote sensing as well. So for example, we can study about say if there is an oil spillage from a ship on a sea. Okay, now it will be present like a film over the sea, and that can be understood using microwave remote sensing. We can study about the roughness, we can study about the wind. So to answer your question, I can't tell you which band is best for water quality because it depends upon whether you want to use optical or microwave. Okay, either ways, you are not directly going to the field measuring a sample of water and trying to assess water quality. You are visually, spectrally trying to understand the same. Okay. With respect to microwave remote sensing, I may not urge you with a specific band, but of course there are several other aspects of remote sensing, like for example hyperspectral remote sensing, that can be used to study about turbid waters. Again, please send me an email and I can direct you to those specific literature with which you can kickstart your study. Okay. So now I'm reading the next question by Saurabh. For 3D DEM modeling, which software is best? 3D DEM modeling. So I am going to interpret your question as for DEM generation, which software is best? Is that so? See, you can either work with stereo pair of images, say from Cartosat and generated them, or you can work with open source raster images that you get from satellites, which you can use for DEM related applications. The best way would be to conduct a survey. You take your total station and then go to the field and then find out the XYZ location of points and try to interpolate it and generate an elevation model. But of course, for large scale studies, say at a national level or at a global level, it is not possible, which is why we use for the open source versions. Okay. Yes, so we are pasting a few links that can help you to understand a little bit more about your question. Okay. So the next question by Vishwa, I'm reading it loud. Does this course require an antenna and wave propagation course? Not necessarily, when we discuss about Doppler weather radars, antennas are, we can't avoid discussing about antennas, say gain of an antenna. All that comes into the radar equation, isn't it, when we were covering the lectures. So it doesn't require you to have a prior understanding about any other course, because we have designed it in a way that it is simple and it is easy for everybody to pick up, even if he or she does not have a prior understanding in electronics. Okay, but if you are, say, somebody who is an electrical graduate, then it of course helps in some of the terms, because it may not be new to you. Okay, but then as such it does not require a full-fledged understanding of other courses for you to understand this course. That is why we have tried to simplify everything. Okay, I hope I'm answering your queries. If not, feel free to type the same in the chat window. And in case I'm missing out on any question, again, feel free to type in the chat window. Thank you. Am I missing out on anything? Not yet? Okay. If you have any queries, please don't hesitate. Just type it in the chat window. That will allow me to read it out loud as well as respond to it. But one thing that I found interesting whenever it comes to microwave remote sensing is that, yes, I'll take the next question by Vishwa, who's asking what are the applications of this course. So as I was saying, you have a wide range of applications for this course, say when you want to forecast convective storms, or say you want to convey to the farmers where exactly they have to cast their nets to catch fish. Okay, because previously when you talk to elders, they will tell you that okay, the wind direction is this, you have to go in a certain direction in the boat, there you will get a better catch. But nowadays we have GPS, okay, system, and there is a large amount of training which is done by the Central Marine Fisheries Research Institute. When you go to a beach next time, I would urge you to look out for those notice boards that tells you the coordinates, okay, Now, we have motorized boats which the fishermen carry nowadays that help to tell them what coordinates they should go to see chlorophyll, that is the food for fish, and where should they cast their nets so that they catch fish. So aquaculture, that is one application that I wanted to insist here. And the next is, say you have say you have an approaching tornado or a storm, okay, and for people to evacuate the place and be safe in some other location, we need to warn them prior, okay, say 3-4 hours prior. You need to warn people so that they can move to another safe location. So in that aspect, to warn people, we need to have better nowcasting abilities, that is using say microwave data. I'm going to specifically highlight microwave data, even though we have a wide range of data products available, because that is the intent of this course. So say using Doppler weather radars, which give you data at every, for one scan it takes 10 minutes to complete one scan in 360 degrees. So you get rich, dense data that can help you understand about incoming convective systems, okay, which helps in forecasting. And if I'm being more ambitious, it helps in nowcasting as well. So, early warning, to get the data, to process it, to use it for generating maps and to disseminate it to public. Okay, data latency is also important here, but then that is one application that is in disaster management. And there are many more, but I'll just try to list one or two that comes to my mind. For example, I say you want to understand the uncontrolled pumping of groundwater that is related to land subsidence. Okay, you want to know whether there is a linkage between both using microwave data. Okay, that is one another area wherein you can use this. And fourth is, you can try to measure important variables, as I mentioned earlier. Say you want to study about precipitation. When you may have seen that in the news towards the end, when the narrator is showing the, they want to speak about weather, you see a black screen and there is white line of India map, and you see some white patches, isn't it? So basically you have optical images, infrared images that can't penetrate through clouds, but they look at cloud top temperature. Okay, when it comes to microwave, the advantage is that they can penetrate through cloud, which means they can physically interact with something known as hydrometeors, which we call as precipitation sized particles, that can help you understand more about atmospheric phenomena. Okay, so that another application of this course is satellite meteorology, in the field of satellite meteorology. So I would say the radar remote sensing, or for that matter microwave remote sensing, has application both in the atmospheric side as well as in land hydrology. And when you talk about GRACE, it even helps in estimating the groundwater tables. Okay, because as they say, mass is not uniformly distributed across Earth. You have trenches, and then somewhere you have mountains. So there is unequal distribution of mass, which means there is unequal distribution of gravity. Think about it. Okay, so all that is understood more by satellites like GRACE, which gives us an idea of the, it can be used to learn more about the linkage of land subsidence and groundwater table and so on. Okay, I don't want to be carried away too much because I love this course. So let me move to, yes, Sampath. So let me read what you have written. I do work mostly in optical, so when I try to see microwave, how to understand amplitude and sigma naught better just than a pixel value. Okay. Okay. So do you remember in one of the lectures I had discussed about how a radar satellite can be, we can compare it to a bat. Okay, of course with bats they use sound waves. Okay, they try to access the location by a process known as echolocation, Okay, and similarly, whenever you try to light a torch and you try to hold it onto the floor, what you see is a elliptical shape, isn't it? Depends upon the incidence angle and of course the elevation. How high are you holding the torch? Assume there's a power cut and you are switching on a torch, you are trying to light the wall. It will be circular at first, but then if you're playing around with the torch, you will find that it gets more and more elliptical if the incidence angle is more, isn't it? So similarly, whenever we try to understand visually about microwave remote sensing, there is a certain instantaneous field of view from where we get the energy that is being captured by a sensor on board a satellite. So I won't urge you to understand the data in terms of pixels, because if you remember, the data has to undergo compression, okay, in the azimuth as well as in the range. We learned about azimuth compression and range compression before it gets transformed to a pixel from an elliptical area or from the field of view. Okay, so the best way to answer your question, the best way to understand it is to start working with raw data. Okay, so I would urge you that instead of using gridded data, you can go to the website, download the level 1 orbital data, which has different resolutions for different frequencies. If you ask me a particular satellite, I would urge you to look at, say, the TRIM or the GPM satellite. Go to level 1 data products in the website, try to download one file and try to look at the attributes. And when you compare it with the website information, you will find that the information you get is from an ellipse which has a different major and minor axis, and the different resolution, it's different for different frequencies that are being used by the satellite. So the best way to understand is download one file and then try to explore the attributes. Again, I'm hoping that I'm answering your questions. In case I'm not, and in case you are requiring more clarity, feel free to type in the chat window. Okay. Now I'm trying to look at the next question. Okay, in India, are there companies working with this data or any scope for a startup, or is it purely government dominated? That is a very so that is a very interesting question. So you see, there are I'm not going to advocate any particular company or any particular startup, but there are many offices that try to use sensors operating in visible as well as in the microwave region to find solutions to their problems. For example, again, I'm not going to name the startup. So we had an interaction with one such startup who had approached us because they wanted to understand the soil moisture for coffee plantations. Okay, and they were unable to use optical remote sensing because it doesn't penetrate the thick coffee plantations. They wanted to rely on microwave remote sensing, so that it helps them in better agriculture, management practices. So there are a lot of startups and companies, absolutely, and it is a booming area, I would suggest, especially with the start of drones. Uh, People have a lot of understanding on what kind of sensors can be placed on a drone to get the desired results. So I won't say that it is government dominated. I would say, in fact, that government is helping us by by giving us a lot of data from several missions that ISRO has launched, which we use for research as well as for solving our problems. So there is not. I think it's a matter of working together. So I don't see any domination by any agency, but I would suggest that they are helping us to learn more about the course. Okay. So the next question is, for better quality of products, should we need optical and radar image of same area for better quality image? Okay. So when you say quality, I'm trying to understand whether you mean accuracy. Okay, so there are studies which try to merge both optical data as well as radar data through, say, wavelet fusion based techniques to see whether it has any improvement in analyzing a particular application. So that is there, but both have pros and cons. Optical data have their own plus minus, radar data has their own plus minus. So I'm trying to understand the quality here. So I wouldn't say quality, I would say for certain applications, merging of optical and microwave data is considered essential, whereas for certain other applications it is not considered mandatory. So they complement each other. That again depends upon which application you want to use for. Okay. So the next question is by Irfan. Can we make DEM from topo sheet map? Absolutely. The Survey of India gives topo sheets and it has certain benchmarks. Okay, benchmarks, known elevation locations. So say you scan a topo sheet, you bring it to the ArcGIS environment, and you try to convert the benchmarks into shape files, point shape files. Okay, and you attach attribute to it which is similar as the height that is given in the topo sheet. Then what happens is in the GIS environment, you have a point shape files, a number of point shape files, each of which is representing a particular height. And then you can use kriging or any other interpolation technique that can give you a DEM, a digital elevation model. So it is possible from a topo sheet map. In fact, it was done by one of my master students. So it is possible. Okay. So again, if you have any other queries, feel free to type in the chat box and we'll try to clear it. Okay. So I'm reading out the next question by Sampath. I guess you are suggesting SLC data. I started working with Novasar data and timely found your course. I registered. Thank you. Thank you so much. I'm glad you liked the course, Sampath, and feel free to be in touch and mail in case you feel there is something that we can help with. Okay. Anything else? Okay, so the purpose of either optical or radar data. Yes, so let me try to understand your question. The choice of using optical data or radar data depends upon what application you want to look out for. Okay. Okay. So anything else? Okay. So the next question is, can microwaves be used to penetrate ground and find out what metals or elements are present with some chemistry? So I would urge you to look up what is ground penetrating radar, GPR. So please search for what is GPR and what does it do and what are the microwaves that are used in GPR and how much deep can it go when you say penetration. Okay. Okay. So once again, thank you so much for joining in this discussion. It was fun to attend to your queries in this mode. And I'm glad all of you like the course, and in case you find any other query or any work that you feel we can collaborate with, feel free to drop a mail and then we can start conversations from then on. Okay? So thank you so much and all the best for the exams.